Hello everyone, welcome to the next class on the testing of the hypothesis. Today we will discuss about the next non-parametric test called as the sample rank correlation coefficient. Myself Dr. Garg, working in the School of Mathematics, Thapar Institute, India. You are feel free to contact me by either of my email IDs or through my YouTube channel for their spreading the education. So we have seen in our last few lectures that there are the several non-parametric tests are there, which are listed as below. So also we have covered the four non-parametric tests in the last video. That is the sign test, Wilcoxon test, Mann-Whitney. It is also called as the Mann-Whitney U test, and so on. And today we will discuss about firstly this, and later on we will work on the next lecture will be on the crucial Wallis test, or it is also called as the H test. So right now we are working here. If you want to see any of this sign, Wilcoxon and the Mann-Whitney U test, you can simply click on these links. Else, click on this link. You will find the testing of the hypothesis playlist is there. Now let's work on the Spearman rank correlation coefficient. So as we all know that how to calculate the rank correlation coefficient. So it is denoted as a RSP between the two variables. So since it is a rank correlation coefficient, so we firstly arrange the series X, we will second series Y, then we will find the rank of X with the help of the positions of their, say for example, if this is 11, this is 23, this is 41, this is say 30, and say this is 21. So what is the rank of the axis? You can easily see that what is the smallest number is here, second number is this, third number is this, fourth number here, fifth is here. Similarly, you can find the rank of the y. Based on this rank of y, you can find their differences dx rx minus ry, or you can find ry minus rx. Then if once you will find, then small d is nothing but my difference between the ranks. Then you can find this rank correlation coefficient with the help of this equation. Remember that this equation is applicable only when there is no tie between the ranks. Look at that. Once we will calculate the Rx, there is no tie between them. On the other hand, if I say my X positions are here, this is 17, this is 14, this is 21, this is 14, this is 17, this is 19, and so on. So then how you find the rank of the X? Look at that. There is a tie between them. The smallest number is 11. Next smallest number is my 14. Now there is a tie between them. So how you rank them? It's a 2 and third. So you can take the average of them. 2 plus 3 divided by 2. So 2.5, 2.5. Similarly, the next smallest number is, if I say one more, 17 is there. So now there are the 3 17 are there. So there is a tie between this position, and this position. So we already make the 3. So now 4, 5 and 6 divided by 3, because there are 3 position repetitions are there. So we will put 17, 5, 5, 5, and so on. We will put them here. Next one is 7, then 8. So there is a tie between them. When there is a tie, then you can use this formula. What is the M here is? M is the number of the elements repeated. In this particular example, what is the M is? So firstly, it's a 14 repeated 2 times. So 1 M is 2. And then 17 M repeated 3 times. So it takes 2. That's why this is a summation. So always remember, when there is no tie, then you have to find the rank correlation by this. Otherwise this. We will see in the next couple of examples on this. So let rho be the population rank correlation coefficient. This is the sample rank correlation coefficient, and this is the population rank. Then we will discuss the two testing of hypothesis. One is for the small sample, second is for the large sample. So when the sample is said to be small, when it is less than or equal to 30 elements. So suppose there are the two random samples, x1 y1, x2 y2, and xn yn, consist of the n pairs, and RSP be the observed value of the rank correlation coefficient. Then our target is to check whether this Spearman rank correlation coefficient which we are obtained, is there any significant difference between the population correlation coefficient, or it is just due to the fluctuation of the sampling. So in order to define this, we need to explain this with the help of the testing of the hypothesis. So we will define the H0 and H1. So we can test the significance of the RSP with this as the test statistics this. Null hypothesis, there is no relation between them, and there is a relation between them. That's why this is not equal. What is the rho is? Population rank correlation coefficient. So what is the procedure we just follow is we firstly define the H0 and H1. Then we will find the rank correlation coefficient by either of the equation, depending upon that whether there is a tie between the rank or there is no tie between the rank. Once you are defining the rank correlation coefficient, we define the test statistics, which is nothing but the RSP. RSP is calculated by using this, and we will check about the critical values. How you can check the critical value? This n is the size. This alpha is called as the level of significance. So based on this, we will find the TC. For example, look at this is the table corresponding to the level of significance for the critical value for the Spearman rank correlation coefficient. So look at this, alpha 1 is the one tail, alpha 2 represent for the two tail. So if I just call as the critical value of 5% with the 7 degree of freedom, sorry, with the 7 population sample size n, so the value is 0.714. So based on this, we will find this TC, and the critical region is here. If it lies in the region, then we will accept it H0. Otherwise, we will reject H0 based on this conclusion. So let's explain this procedure with the help of the numerical examples. So consider the following information given about the cholesterol levels of the 7 adult localities are there. So X and Y are there. Obtain the rank correlation coefficients and check whether there is any significance of the negative relation between the X and Y. So you have to firstly define H0 and H1. So what is the given in this statement? You have to check whether there is a negative correlation coefficient. So since this is no equality in here, so it means this is my H1. So what is the opposite of this is? Greater than or equal to 0. So this is my null hypothesis and alternative hypothesis. So this is a left tail, that is called as the one tail. What is the step 2 is? You have to find the rank correlation coefficient. We will use either this or the repetition are there. You can see that whether there is any repetition value in the X, no. Whether there is any repetition value in Y, no. So it means we can use this. Now how you find them? Look at in the HDL X, what is the smallest number is? 23. So you can find the rank of X firstly. So what is the smallest number is? 1. So you can find the rank as 1. What is the smallest? What is the second smallest number is? 31. You can find this as 2. What is the next number is? 33. Find the rank 3. What is the next one is? 36. 4. Then 39. Then 6. This is 7. So this is the rank of the X. Similarly, you can find the rank of Y also. So how you find the rank of Y? What is the smallest number is? 50. This is 1. Next one is 72. 72, 3. Then is 80. Is a 4. Then is 90. 5, 6, and then 7. So we can find here. Now in order to find the D, that is a difference between the ranks Rx minus Ry. So you can easily find 4 minus 4, 0, 5 minus 3, 2, and so on. Now since you need the D square, so we will calculate D square also, and so on. So we can substitute. Now there is a summation of them, so you can find the total. So once you, what is the N is? How many numbers are there? N is my 7. So you can substitute in this value, you will get here. So that's my step 2. What is the step 3 is? That is the test statistics. This is nothing but the RSP. What is the RSP we have computed? Minus 0.928. Now we need the critical value. So what is the value of the N is 7. 5% is level of significance. So look at the table. The critical value for the 5% is, now look at that. What is your H1? This is less than 0. That is a one tail. So look at for the one tail. That is in this case, this is the one tail and this is the level of significance 5%. Value of 7 corresponding to 5% is 0.714. So this is the value for here. So the critical value is RSP, whatever the value is less than of this. Now check whether this satisfied or not. So since this is satisfied, so this the value of this is satisfied, so we rejected H0. So we will reject H0 and this is accepted. So what is the meaning of the H1? There is a negative correlation coefficient on them. So we conclude there is a negative relation between the variable HDL-X and the LDL-Y cholesterol in the population. So this is a simple way. Look at one more example, so it will be clearly explained to you. Compute the rank correlation coefficient for the following grades and test whether there is a significance of any negative correlation. So how you define the H0 and H1? So look at that, what you want to calculate is there is a negative correlation. So it means this is less than 0 and H1 is greater than equal to 0 because there is a negative, so it's no equality, so that's why this is H1. So this is my, again, the left tail. Now you want to calculate the step 2. What is the step 2 is? You have to find the RSP. So you have to arrange the mathematics I call as the X, economics as my Y. So I can represent here. Now look at that, which formula is used. Is there any repetition inside it? Yes, look at that. 88 is repetition. Okay. 89, no, 88 is there. Is there any that? Yes, 86 is repetition and so on. So it means you have to use this formula. Now rank of the X. What is the smallest number is? 82. What is the next smallest number is? 83. Only one time. So it is my 2. What is the next smallest number is? 84. This occur only one time. So here and this. What is the next smallest number is? 87. This occur 2 times. Now what is the position at here and here? So we already put up the 4 position. So it will be 5 or 6. So it's 5 plus 6 divided by 2. So that is 5.5 and sorry, it is 86 firstly. So 86 is my 5. Now it's 87 occurred 2 times. So what is the position is? Either 6 or 7. So it is here 6 plus 7 divided by 2. So now it's a 6.5, 6.5. What is the next smallest number is? 88 one time, 2 times. Okay, so how many numbers we have already put up? 1, 2, 3, 4, 5, 6, 7. Now it's 8 and this one is a 9. So now 8 plus 9 divided by 2. So that comes to be 8.5, 8.5. What is the next smallest number is? 89. That is only single number. How many elements you have put up? 3, 4, 5, 6, 7, 8, 9. So this is my 10. And then after that 90 occurs 2 times. So it's 11 and 12. So 11 plus 12 divided by 2, 11.5, 11.5. Similarly, you can find the value of the rank of Y also. How you find the rank of Y? What is the smallest number is? 85. Yes. So this is my 1. What is the next smallest number is? 86. It occurs 1, 2, 3, 4 times. So it means second, third, fourth and fifth, 4 times divided by 4. So after solving this, what is the answer is? 14 divided by 4. So this is 3.5. So you can put here as 3.5, 86 here 3.5, 86 here 3.5, 86 here 3.5. Now what is the next smallest number is? 88, 1 times, 2 times, 3, again 4 times. How many elements you have already put up? 5 ranks. So this is 6, 7, 8, 9. 6, 7, 8, 9 divided by 4. So once you will solve it, it gives 7.5, 7.5 here. Then what is the next smallest number is? 90. It occurs only 1 times. So how many elements you have put up? 4, 7, 9. So it by 10. And then after that this is 11 and this is 12. So these are my ranks are there. Now in order to find this, we will find the difference firstly. This is 4 minus 7.5, 2 minus this. Now you need the d square. You will calculate here. Now in order to substitute this value in this equation, we know this value. What is the value of the m? So look at that. In the x, how many numbers are repeated? So look at that. 87 appears 2 times. So first m is my 2. Any other repetition? 84 appears 2 times. So that's the value of this second m is 2. 90 appears 2 times. So this is my third m is 2. Any other repetition in the x? No. Look at for the y. Is there any repetition? Yes, 86 appears. How many times? 3, 4 times. So that appears here. This is for the y, these 88s, and this for the 86. Look at these 4 are there. So this is the way you can find the value of the m. So after solving this, you will get this as the answer. Now step number 33 is R of SP is here. Now you need the critical value at n is equal to 12 at 5% is level of significance. So look at that, this is n12 at 5% level of significance is 0.503. So look at that, it's a 0.503. Now check whether this value is satisfied. This is a critical region. You can see that this is satisfied. So we again rejected H0. If this is not satisfied, we accept H0. So since this is rejected, so it means this is accepted. So there is a negative relation between the grades of the student. So this is the simple procedure. You can solve it with the help of the small sample. So this is one more example. You can find the rank correlation coefficient between the A's and the FATs. So you can consider this as X, this as a Y. So I just give you a hint how you define the H0 and H1. So you have to test the level of significance, positive correlation. So this is here and the opposite of this is this. Rest you can try yourself. The critical value is given to be here. Similarly, one more example. This is given to you. You can find it. Test if there is a significance of any correlation. So since it is not given that whether it's a less than or greater than, so it's a two-tail. So this is my two-tail and this is my temperature difference. You can consider X and then Y and then you can solve it yourself. Okay, now the next part is we will consider about the large sample when n is greater than 30. So that in that case, whenever n is greater than 30, we will define the null hypothesis this. There is no correlation. On the other hand, once we will define this, then the Z value is calculated as here. This RSP is calculated with the help of same, whether there is a tie or not. Multiply with the here. Then we will apply the normal test to check whether this is accepted or rejected. Look at very simple example is I consider same example of the HDL and cholesterol. Instead of taking the 7 adults, I consider as the 35. So look at that, n is greater than 30. So it's my large sample. So what is given to you? N is my 35. What is given to you that? And the rank correlation coefficient is found to be. So what is given to you? RSP is already given to you. Here. Is it significant of any correlation in the population at 1%? So what is your H0 and H1? Is there any correlation? So this is here and this is given to you. These are n and this is given to you. Then you have to define the null hypothesis. This is there is a relation and there is no relation. Then you have to find the step number 2, RSP. This is already given to you. Calculate Z. How you find RSP? Square root of n minus 1. So 0.64. What is the n is 35 minus 1. So that is the way you can calculate that. This is come to be 3.75. Now since it is for the large sample, so we apply the Z test. So the critical value, what is the level of significance is 1% and it's a two-tail. What is the level of critical value of the Z test for the two-tail is 2.58. We already know that. Since it is a two-tail, so it drawn on both sides. Look at that 3.73 where it lies. 3.73 lies here in the rejected region. So what is that? Since this value is greater than of this, so we rejected H0. What is your H0 is? We will look at that. What is my H0 is here and this is not 0. So we rejected. So this is rejected and this is accepted. So not equal to means there is a relationship between the cholesterol levels at 99% is confidence. So this is a simple procedure you can apply for the rank correlation coefficient, whether it's a small sample or the large sample. We will see in the next class, that is the crucial one is H test, and this is also very important test is there. Till then, if there is any doubt or if you missed any of the video, You can click on this link and share with your friends if you find it's a useful. Till then, happy learning, best of luck.